All right, today's job is a comfort consult here on Oak Island. This beach house here is experiencing a lot of moisture problems, condensation, and biological growth on some of the ceilings, especially by some bath fans and some can lights. So this comfort consult is very in-depth. I use the same process whether or not I am diagnosing a comfort problem, a room temperature problem, a humidity problem, an indoor air quality problem, bad smells, high energy bills. This comfort consult is the basis that I perform all my tests. And then obviously, depending on what the specific problems are of the house, and maybe I may get into some things a little bit more in depth. But I'm going to show you my process here really quick. Try not to make this a really long video, so at least you can see some of the work that I do, and then what the report looks like at the end. So one of the things that I do early on is just a walkthrough with my hands in my pockets, and I am documenting the windows, the walls, the gutters, all the elements that have to do with keeping moisture away from the building. I document whether any of those have failed. The other thing that I'm documenting is vent terminations and just making sure that the math adds up with the exhaust units that we have inside, like bath fans, kitchen fans, dryer exhaust, that they match the amount of terminations outside. I know where each one goes where. One concern that I see is that there are soffit vents all around the perimeter of the building, but I don't see any ridge vents or gable vents that allow natural ventilation to take place. So if that's not happening, then the dew points inside the attic can really spike, where just the moisture levels are really, really high because we're not getting that moisture out of there. So I'm going to do a little bit more investigation, and this may be something I'll come back to. All right, so complaint is high humidity in the house, and then some of the black stuff is growing on this ceiling here. They've already replaced the ceiling. They just put a temporary one up here, but there was just covered, he showed me pictures, all this entire ceiling, even running down the walls, was covered in biological growth. Going upstairs, he also said these can lights here were also showing signs of biological growth coming out. Upstairs bathroom, same thing, some biological growth coming here. And if you notice, we've got a supply vent and a exhaust vent very, very close together. I'm sure we're going to find something interesting when it comes to that. Okay, so I'm going to do a quick walkthrough around the house here. Opening all the doors to pantries, to bathrooms, to laundry rooms, and just getting a good idea of what things look like in the house. And also, before I start my blower door test, I'm probably going to go ahead and test the HVAC. It's rather cool out there right now. The outdoor temperature is roughly close to the indoor temperature, so I'm not going to see a lot of thermal imaging until it warms up. So we'll go ahead and spend our time wisely. We're going to go ahead and check the HVAC system out first. All right, so here is the HVAC system kind of jam-packed in here. We've got an air handler. There is a zone module in here. We've got a zone damper here. I think there's another zone damper back there. Someone put in a dehumidifier here. Customer thinks that the dehumidifier was not ducted correctly, so we'll look into that. They're also thinking that the house is going into a natural negative pressure, so we're going to be doing some dominant duct leakage and some actual duct leakage testing. And we're just, again, trying to do repeatable processes, so we're going to be putting this system through a full measure quick and just determining whether it's acting correctly as well. All right, 3-ton Lennox heat pump out here. We're going to go ahead and get our probes hooked up, and we'll start the measure quick process. And really my objective here is to determine the delivered capacity of the system, and also whether or not I see anything else that may require some additional attention. This is the Oasis 105 from Santa Fe, one of the best dehumidifiers that they've made so far. And when the AC unit cycles off, I feel cold air just blowing all around here, which tells me that supply air is coming through here. There's no backdraft damper. There's nothing that prevents it from just turning it into just one big loop, which is essentially like a bypass, an open bypass. They probably stole the bypass from the zone system, and what that's doing is making the air, because we're recycling cold air, it's making the air that finally does come out of the registers really, really cold, and that could lead to condensation issues also. The other thing is they have not installed this per any of the recommended instructions from Santa Fe, and you are sending that air back into the return. That could actually derate, because you're throwing hot air on the coil here, that could derate the main air conditioning's ability to dehumidify. That is not a recommended installation, especially in this climate, so that's a problem. All right, we got our static pressure probes in. We've done a visual inspection of both the indoor unit and the outdoor unit, documented all that, pictures. And now it's just time to run the unit as it is currently ducted in with this dehumidifier. This visit that I'm doing here is simply read and report. All right, so a couple things about this testing. First of all, I'm using my Supco IDVM 550 meter. This talks to measure quick. This is a power quality meter where I can read power factor and wattage. All right, we're going to quantify the airflow using the True Flow grid from TEC. We're going to put the right plate in there. We're going to read this return, the other return. We're going to put that in measure quick. That way we have an accurate airflow, which is one of the most important things you can read about an HVAC system's performance. We're going to make sure that's accurate, so the measure quick gives us the best diagnosis possible. So as we can see, the system's showing a little bit too much subcooling. Liquid line temperature is a little bit out of range. It's actually an indication of a possible overcharge. So we're just going to keep an eye on that. Everything else is looking really normal here. The system is putting out really close to 3 tons. So Measure Quick is telling us a few things. Low load on the evaporator, of course, we know that. Dirty condenser coil or non-condensables. The condenser coil, because of its age and being so close to the water, is starting to deteriorate. System may be overcharged with refrigerant, and that is the case. Just need to take a little bit of refrigerant out of it. All right, so what I've done is I've shut down the downstairs zone, so that only the upstairs zone is calling. And take a look at what the zone module is telling me. My discharge air temperature, because I have taken away half of the duct system from this 3-ton system, my discharge air temperature is going all the way down to 42 degrees. Now, at some point around 40 degrees, or wherever the zone module is set at, it will actually turn the outdoor unit off so that the unit doesn't freeze up. So what they've done with this zone system is they put a giant unit in here. They've divided it into 2 zones with 12-inch ductwork on there. So what happens when you throttle that system all the way down to one 12-inch duct? You got a 3-ton system. Well, you've got a system that puts out really cold air that's more than likely going to sweat no matter where it's located, even in a conditioned space. And then you're going to get intermittent trips on that low temperature. So we've just got a very poorly designed system. The equipment itself is functioning correctly. It's just how it was designed and installed, which is the problem. All right, so everything was looking pretty good until we started running this system one zone at a time. And then all of a sudden, the system performance really took a nosedive. And that's why it's really important when you're working on a zone system to operate it in various scenarios, one zone at a time, as well as with all zones calling, because how it operates in each scenario can be completely different from the next. Honestly, the best thing they can do is just disable the zone system, run it off of one thermostat. That way, because when it runs off of both zones calling, the system runs okay. It's when it runs off of just one zone that we have a restriction in airflow. So the best thing they can do is just get rid of that zone system. The next step is we're going to go ahead and do a blower door test. We're also going to test the ducts for leakage. Again, we're trying to look for places where humidity is coming in, or places where the house is not performing. We'll use a thermal camera. Now that it's a little bit warmer outside, we'll see those heat plumes coming in, and then we'll be able to give some really good recommendations on how to improve the humidity control of this house. Let me talk about some of the tools that I use in order to do these kind of tests. Obviously, I've got a blower door here. I use a Retrotech one. There's other brands that are really good, like the Energy Conservatory. They make the True Flow Grid, and I absolutely love this. This allows me to quantify airflow. And then also, I happen to have a Retrotech duct tester. Obviously, they're not the only ones that make it. There are other great brands out there like TEC. I just happen to have a Retrotech, and I love it. In addition, the DM32 dual channel precision manometer is essential if you're going to do any kind of blower door or duct testing using Retrotech equipment. So I got one of those. That's the DM32. Another great tool is the Retrotech Solo. This is a single channel precision manometer. This is great just for getting those micro pressures when you don't need to make a Bluetooth or Wi-Fi connection. Just reading some pressure in the building. I've also got the TEC DG8. This is also single channel manometer, but it does connect to Bluetooth and Wi-Fi. It works with Measure Quick, and it is essential for using the True Flow Grid. I've got a thermal camera from Hike Micro. This is very precise. I absolutely love it. It's about the size of a cell phone, and it's very rugged. All right, next thing we're going to do is a Retrotech duct leakage test. This is because we want to separate the duct leakage from the envelope leakage. So we're going to first start with quantifying our duct leakage, and then we'll move on to a blower door test for envelope leakage. Okay, so the duct system was tested for leakage, and it leaks at 8.6%, and that's with absolutely no efforts even sealing up the air handler. Also, there is a very leaky dehumidifier down there, so despite all that, it's only 8.6%. So the problem here, I don't think, is duct leakage. All right, so the next test is an envelope leakage test using a Retrotech blower door. This, again, is to separate the leakage of the ducts to the leakage of the envelope, and then we'll walk around with a thermal camera and try to figure out where the heat, which is the infiltration, where all that is coming in. All right, we've made sure that we close that damper to that fireplace right there. We're going to start the blower door really, really slow and keep an eye on that and just make sure we're not sucking any ashes in. Okay, well, this house tested out at 5.56 ACH 50, and the CFM 50 on it was really close to the actual square footage, which this house is relatively pretty good. Obviously, there's room for improvements. Code is 5.0 ACH 50. This house tested at 5.5. I think what we're going to find in this house is a localized leak that is creating the moisture problems, not a systemic house-wide leak. And just because we didn't find that doesn't mean that it wasn't worth it to do all these tests. Being able to confirm that the ducts leaking or the envelope leaking is not the problem is equally as important as finding what the problem actually is. All right, so the next thing we're going to do is set this blower door just to slightly depressurize the house, not the full negative 50 pascals, but maybe around 20 to 25. That way we can start pulling in the heat and the humidity from outside. We're going to see that heat with our thermal camera, and we'll be able to locate and pinpoint where these envelope leaks are that are contributing to the moisture problems. All right, here is the bathroom that had a lot of the biological growth, and we can see a lot of heat is coming out of that exhaust fan, as well as a lot of heat around, good grief, where the sheetrock and the ceiling meets the wall. Obviously there's no trim there. The trim is not meant to do any kind of air sealing. We have got a lot of leakage, even some missing insulation probably, but these plumes that you see is air leakage. And yeah, it makes a lot of sense that this room would have really high humidity problems. Places like this floor boot border cooler spaces so that the thermal imaging is not going to pick up a leak, but if we do a smoke test, then we definitely will pick up a leak. I know it's kind of hard to tell, but I can even feel the air coming up around this boot that isn't sealed. So this is just basic stuff that should have been done in the first place, but all these contribute to some of the issues they're having here. And as we come upstairs, we're going to see that penetrations like can lights and supplies, smoke detectors, and just all these penetrations are leaking. Now, again, we're looking for not a sharp contrast of colors, but a plume, a feathering. That's indications of air leakage, and that's exactly what we're seeing here. This upstairs bathroom was another spot for really bad biological growth. As we can see, we've got heavy leakage through these penetrations. My guess is that the flapper on both of these exhaust fans, upstairs and downstairs, is not sealing too well. Also got a little smoke puffer from Cirrus. I'll probably end up upgrading this. This is great just for visualizing what direction air is coming in, being able to show somebody where the leaks are. Sometimes you can feel the leak, but you can't exactly pinpoint where it is. Well, using some smoke like this is very helpful. This upstairs ceiling boot, just as I suspected, no sealing around the boot, and obviously some really nasty stuff growing right. All right, one last test that I do is I get asked very often, well, can't we just pump some fresh air into the house and pressurize it? And that way none of these leaks really matter because we're pushing conditioned air out. In order to positively pressurize this house to around 2 to 3 pascals where it could actually push some air out, it would take 160, 170 CFM. That is more fresh air this house needs. It's more fresh air than that Oasis 105 dehumidifier can handle downstairs. And so in this case, it simply is not realistic to be able to pressurize a house that is as leaky as it is. Even though it's not very leaky, it is about average leakage. You would have to pump in a bunch of air to try to pressurize this house, and in the end, it wouldn't be worth it. All right, another test that I do is a worst case depressurization test, and what I'm doing is running all the exhaust in the bathroom, the kitchen, and the dryer. And I'm trying to figure out at what is the worst case depressurization of this building. And in this case, it would be negative 3.5 pascals. That's not too bad. Again, if it was a really leaky house, then this would be a lot of air. But the other thing that helps us to do is if there are any combustion appliances in the house, which in this house it does not, but let's say you had a 80% furnace in a closet, you would want to know this number, because if for some reason all those devices were running and you were running the gas heat, you could actually be pulling carbon monoxide back down through the vent. So it's really important to know what that worst case depressurization number is. One of the tests that I do is a dominant duct leakage test, and I've got the HVAC system on, all the doors in the house are open, and I want to see whether this house goes positive or negative when that happens. If you have a supply duct leak, then your house will go negative. If you have a return duct leak, your house will go positive. But just because you have a very low to negligible number does not mean that you're in the clear. It really should be taken within the context of a blower door, because if you have a really leaky house, and you're not going to be able to build pressure in either direction anyway. Also, you could have supply and return leaks that cancel each other out, and that would also cause that number to be really low. But it's just something that I document. If you see a really high number, especially with a leaky house, then you know you've got a really big problem. Now we've closed all the doors of the house, and we want to see whether the house goes positive or negative. It normally goes negative, especially when you have central returns, because those returns are still pulling throughout the house, but they're not being replenished by the supplies because the supplies are being closed off behind doors. Now, this house also has a pretty good transfer grill system above a lot of the bedrooms, but not all of them. And we're seeing that here because we're seeing a very slight negative pressure. That's because not all the supply air is getting back to the return when these doors close. This house goes negative, and during these scenarios is when we can be pulling in humidity. Behind this door is a master bedroom. There is no return in there. There's no transfer grill or jumper duct. So when this door closes, we can expect this room to go positive with reference to the main body of the house. That's exactly what's happening here. So you can see we're going 10, 11 pascals. That is a lot of pressurization. That air is not only trying to escape out through the door, but it's also going to try to escape through the cavities in the wall, the penetrations, all the leaks in the envelope. In this room, in this master suite, when this door is closed, that air is leaking out, which means that that air has to be replenished by unconditioned air leaking in from somewhere else in the house, and that's a problem. So what do we do about it? The TEC has the Remulator. It's a cool little tool, and I've used it before in some of my videos, but we're going to figure out what size passive return we need to recommend for the master suite. All right, as you can see, now we've cracked this door open to where the pressure is right around 3 pascals, which is an acceptable pressure difference. And what the Remulator allows us to do is measure what that gap is going to be. It looks like a 2.5-inch gap in the door gets us the pressure that we want. So what size passive return grill does that equate to? Well, a 2.5-inch gap is going to need to move around 370 CFM. That is equivalent to a 20-inch jumper duct. That's huge. But also it would equate to 300 square inches of passive return. So essentially this this master suite would need a giant jumper duct or passive return. That is not feasible. What this should have had was its own dedicated return. Whenever I design a system, I always put a dedicated return in the master suite because you have so many supplies that are behind that door when it closes. But really, in the absence of being able to fix this mechanically, what we're going to have to tell them is that they absolutely have to keep that master suite door open at night and whenever it's not in use, and only close it when they need privacy for a few minutes, because when they leave it closed, we have a huge pressure difference and we are driving in moisture. The other bedrooms in this house have transfer grills, and these are passive return paths. And because of that, and the fact these rooms are smaller, they don't have as many supplies behind them, we don't have a very significant pressure across this door, so I'm not really worried about offering a solution for these bedrooms. The last thing that I do is use Conduit Tech to perform a heat load calculation on the house. Conduit Tech is going to recognize walls and windows and doors. It's going to measure everything about the house, and it's going to perform a Manual J certified heat load calculation. This is going to allow me to understand whether the HVAC system is oversized or undersized. So it's really helpful to be able to do this as quickly as Conduit Tech allows you to do. When I'm done scanning the house, I can just do some minor touch-ups. I got to do the upstairs next, and then I'm going to have me a nice block or a room-to-room Manual J certified heat load. So here's the interesting thing that Conduit gave me. I broke these two zones down, first and second zone, exactly how it was zoned by the contractor. And take a look, we got a 3-ton unit, and they were putting 3 tons of air into a second floor that only needed 6,000 sensible and 850 latent for a total of right around half a ton. So 3 tons going into a zone that only needed a little over half a ton. The total cooling needed for this house is 23,154, and that's broken up latent and sensible, as you can see. So we've got a 3-ton unit really going where a 2-ton, maybe a 2.5-ton would have worked. That is not helping this situation with high humidity. It's not so grossly oversized that I think that we need to immediately rip out this unit, but definitely when it comes time to replace it, we need to go down in tonnage and capacity so that we can match the actual load. And finally, I try to install a Haven monitor in every system that I do a comfort consult with. Now, I was not prepared to be dealing with Flex here. This is, I'm going to just go on record and say that is not how you install a Haven. This is a temporary installation to monitor over the next 2 weeks, but my plan is to propose to them some permanent solutions which will require a permanent installation of that Haven. So I'll put a straight piece of pipe in there, drill a hole, do it right, and also a controller which will control this ventilating dehumidifier that's just kind of tossed in here. That'll be installed correctly, and obviously some duct modifications and controls modifications and stuff. So I'll have a chance to come back and fix that right. Please don't roast me. But for now, at least we've got a Haven monitoring the air, monitoring the temperature, humidity, VOCs, particulate matter, and we're going to leave it in for a couple of weeks and then pull a report and see what insights that gives us. Well, it has been a long day. I've been here on site for close to 8 hours. And just so in summary, what I've done to diagnose the humidity problems in this beach house. First of all, we checked the HVAC system, did a full system assessment on it, performance, measure quick, all that good stuff. We ascertained that the system doesn't really have a lot wrong with it other than the fact that the zoning controls, when they allow only one zone to run at a time, especially the upstairs zone, which is a really small zone, you can't force all 3 tons worth of air into that one little zone. And so I'll be recommending to get rid of that zoning system and just go to a single zone system. If they really want to have a zoning system, then they're going to have to rip apart some drywall and access some ductwork, because we need to run bigger ductwork and do all kinds of modifications, which I don't think they're going to do. So the easiest thing is to disable the zoning system. Moving on to the building envelope, we did a full blower door test. We ascertained that the building leakage was right around average. We didn't see any systematic leakage with the building other than what's normally found: penetrations, can lights, HVAC vents, electrical. But the main issues were the bath fans look like they don't even have a functional backdraft diagram because a bunch of heat and humidity is coming in through them, and the bathrooms are the areas that have the most biological growth in them. We tested the duct leakage, and the ducts were not any more leaky than what an average system would be. We didn't really find any silver bullet there. Some measures were taken to seal the ducts anyway, so I didn't really see much problems there. And then we did some pressurization tests. We closed doors, we turned on units, we turned off units, we turned on exhaust, we turned off exhaust. We did all these different combinations to try to figure out what scenarios does the house go into a negative pressure, which areas of the house go positive, which areas go negative, and try to determine what recommendations that we need to give so that we can neutralize those pressures, because those pressures can drive in heat, moisture, and pollutants. We also did a heat load calculation, and there's 2 tons of load on this house. It's got a 3-ton unit, and then the upstairs only needs about half to 3/4 of a ton. And when the upstairs zone calls, as they normally call more than the downstairs do, all 3 tons is trying to force its way into a zone that only needs 3/4 of a ton. And finally, we installed a Haven central air monitor to take a look at the VOCs, the humidity, the temperature, the airflow, the particulate matter. Just kind of keep an eye on those things while I'm not here over the next couple of weeks. We may find some insights that may affect what our final recommendations are. So once this invoice is paid, the customer will get my field report with a bunch of pictures in it, my field observations. I don't really go into a lot of conclusions in that report because I want a chance to digest it and take a look at everything. About 2 weeks from now, I will send him a final report, which is really cleaned up. It's got the relevant pictures, a good explanation in homeowner language that they can understand what's going on with the house. I'll have some recommendations, I'll have some pricing, and then we'll also have some data from Haven so that we'll be able to base those recommendations on that as well. So this is a very high-end service, and not everybody's going to see the value, not everybody's going to have the budget for this, but if you really want to solve humidity problems, we need to test the house, and we need to perform a bunch of tests. And that way, not only do we find out what's going on with the house that's causing the problems, but most importantly, we find out what isn't causing the problems. And so we don't spend money doing things that aren't really going to move the needle. So I feel like this is a very valuable process, but obviously you've got to have the right homeowner. If you have any questions about the comfort consultation, if you're a homeowner, reach out to me. I'll be happy here in the Brunswick County area to give you an estimate on what it would take to do that at your house. If you're a contractor that wants to get involved with those things, reach out to me. I'd be happy to give you some training, some consultation service, whatever that you think you might need to get there. That's all for now. Thanks for staying with me this entire busy day, and as always, work safe.